right, ladies and gentlemen, sorry about that. Once we plug into the calculator, we solve for about 1.215, and when we, I'm sorry, 1.2125, and when we look at our significant figures of our given values, we have to round to 3 significant figures based on the 19.4 grams of oxygen. So we have to make sure that we keep in mind that the significant figures are one of your objectives for this unit, and the reason we learn them is this is where we start doing more of those calculations. We will need to apply that knowledge. Now, when we take a look at the potassium dichromate, remember that was one of the ones you had to calculate on your own, where we should have gotten about 294.2 grams in 1 mole of that. So again, our given value of the potassium dichromate, we're solving for moles. When I do 19.4 divided by that value, I get 0.0659 moles of potassium dichromate. Again, rounding to 3 significant figures based on the 19.4 grams. Our rule of thumb for all of our molar masses is that we're going to round to 2 decimal places. This is relative to the way that we'll be calculating them based on your periodic table. Your periodic table represents them all with 2 decimal places. So that maintains consistency with those values. Now, the other thing that we can do is we can convert between moles and number of particles. When we take a look at these questions, number 11 and 12, instead of caring about the mass, this time we have to take advantage of Avogadro's number. This number will be the same no matter what. So I will never have to look up anything relative to a particular element like we did for mass. Mass is specific to the type of substance. The number of particles in 1 mole is always the same no matter what. So if I have 5.67 times 10 to the 14th atoms of carbon, you'll see that that number is written first. That's our given value, and I want moles. I have to create the right version of the fraction to convert this. Now, in every mole of anything, we have Avogadro's number of particles. So I have to include those units because that justifies what I'm canceling out. Moles of carbon is what I want, so that is the only unit that is remaining. When we calculate that out, your calculator reads 9.4186 at least times 10 to the negative 10th moles of carbon. We're going to round to 3 significant figures based on the 5.67 in the atoms of carbon. Now, let's take a look if we were instead looking at molecules of CO2. In this case, I'm going to be dealing with a much larger particle, but the moles and molecules relationship is exactly the same because it's a particle not based on the particular substance. My conversion factor is identical. So in this case, because the conversion factor is the same, the value is the same. But if I'm looking at carbon, my individual particles are carbon atoms. If I look at CO2, have a carbon in the middle bonded to 2 oxygens on each side. So the particles are of different sizes. The masses would not be the same, but the number of particles in a mole is identical. Now, sometimes it is nice to have a hint or a helpful tool to decide what that conversion factor, that fraction, should look like. The chart that is in your notes is a way to help with that. So if I was going to look at how to use this chart, I care about the end of the arrow and the point. Whatever is my starting unit is going to be at the end of the arrow. For example, the grams with the green arrow would be my starting. If I was said, hey, I have 19.4 grams, just like we did in our problem. Then, the fraction I would use would be mole over the molar mass in grams, because that will make sure that I cancel out the unit I'm starting with. My final part will be then that I end up in moles. However, if I was given moles, like let's say I had 3 moles of a substance, and I said, how many grams do I have to flip the fraction upside down. It'll be the same process. I still need to look at the periodic table and determine the molar mass based on the atomic mass units, but change the value, change the unit to grams. But now, because moles is what I want to cancel out, that has to go on the bottom. The process is the same for the lower calculations when I'm dealing with number of particles. And if I have to convert between both, I just continue on the pathway. If I wanted to go, say, from atoms or molecules to grams, I just go through both arrows and require 2 fractions. Mathematically, you can get away with doing all of these simply by choosing the setup of the fraction that will cancel out your units. But if this tool helps you and it makes sense to you, please use it. If you're kind of like, dude, I got it before and you're confusing me, go ahead and let it be. Just do the calculations using the fraction method that you learned the day before. We will then go over a lot of this information in additional practice when I return.